That's a gotcha for some of you. Everything tests okay, but then there's a nest in there. Why did they do that? We're gonna have to talk to the Atwood engineers, but all I know is the spec for the Atwood is a plastic plug. It got too hot and fire shot out of this thing, and it tripped this thing off. It melted it, it failed. Yep, that's magnesium. Well, hi folks, this is Darren with My RV Works. We've got a pile of water heaters here, and there's more around the bend. Today's the day I'm going to be taking them to the scrapyard. But before I got rid of them, I wanted to maybe give you some benefit of how these things work, what they do, before we just get rid of them. Maybe there's still one more punch left in these things. This water heater leaked from the inside. Now, the Suburban water heaters have a steel tank. As opposed to the Dometic Atwoods, which have an aluminum tank. So here we see this guy was ruptured. Why does he rupture? Right there, okay? Because he wasn't winterized, okay? So if you have either tank, the steel or the aluminum will freeze. So when you winterize your RV, if you're gonna go through a cold spell, get the water out of it. You're going to bypass your water heater. Normally, I'm just looking, none of these have the bypass kit. So normally on your back of your water heater, you have the cold line coming in. Let's flip that around and show you that. Okay, cold water comes in on the top. No, backwards. Cold water comes in on the bottom, hot water comes out of the top. Cold in on the bottom, hot out on the top. Sometimes you will find a check valve right here. Not always, but sometimes you will find a check valve which only lets the water go out of the water heater, does not let the water come back in. Now, why would they do that? They might do that because they've got some kind of a fancy bypass system that they've put on where you only need like one valve to change it. But another benefit, I do like the check valve, because if you're taking like one of these military showers, and you turn off your hot water, you get your water right, and then you like turn it off. If you have a check valve, all that hot water that you've got in your line isn't going to flow all the way back into your tank, which may not be at temperature. So with a check valve, water only goes one way. Get that hot line filled with hot water. Check valve does not allow that hot water to flow back to the tank. So I am a fan of putting a check valve on the outfeed side of your water heater, and there's where it would go. You could get the kind that screws in directly to the back of your water heater, or you can get an inline kind if you want to add one. Now here's one. You will know it's a check valve because it's, I don't know if you can see that, but it's got an arrow going in that direction, and you can't see through it, as opposed to a union where you could see right through it. So this only allows the water to go one way. So you could put that in line right here, and it serves the same purpose as the one that you screwed in. Really simple. If you've got PEX, cut it, slide this in. You now have a check valve where the hot water only goes one direction. Nice benefit. Also on these check valves, I'll mention this. If you've got a water pump, which I know I've got some over there that are going to be going away, and your water pump has failed, and you don't really use a water pump that often, even if you do, then you could put a check valve in that water pump on the outfeed side of your water pump. So therefore the water will be going through the water pump, leaving the water pump, then you go through the check valve, then you go into the rest of your coach. So if you have a situation where your city water connection is working its way through the water pump, which it should not do, and you know that it's doing this because your freshwater tank is overflowing, then you don't really need to put a whole new water pump in. You can, that's fine. But in a bind, check valve on the outfeed side of your water pump will prevent that from happening. I don't know if these are like 12 bucks or whatever, but that's a lot cheaper than a $100 or $150 water pump. So I'm done on that. Let's move on. So water heater, notice I did not say it's a hot water heater. Let's think about that for a second. This is a tank, and you fill it with cold water, and it heats the water, making it a cold water heater. Now this one's got a fancy feature. This is the motor aid. Those of you that might have a Class A, a Class C, and your water heater has a motor aid on it, that's what this feature is right here. This where these little radiator hose things are attached, these little black hoses. It just basically touches the water heater right there. That right there sums up the motor aid portion of the water heater. You run your antifreeze from your engine through it. It touches it right here. Got a really nice, boy, they stacked some nickels on that. Really nice aluminum weld bonded there, and it goes back to the engine. Now, on your older Atwood water heaters, yes, I know, Dometic bought Atwood, but there's still millions of Atwood water heaters out there, okay? Your heating element is going to be on the back side of your water heater. And to get to it, it's there, okay? Not always fun. We've done jobs where we literally have to take an entire cabinet apart we could see it, and we could probe it, and we can get our meter on it. But you can't really get a tool on here to unscrew this thing. We did an Airstream one time. We had to take the whole front bedroom apart, the bed, everything, just because the way they had it all assembled, just to get the heating element out of the water heater. So, not a big fan of that. The new Dometic water heaters, they put the heating element on the front. Thank you very much, Dometic, for doing that. I always hated to change these out on the back side. Sometimes you get lucky, but it never was fun. Heating element on the back of your old Atwood water heaters. On the Suburban water heaters, the heating element is in the front, right there. This is a Suburban, this is an Atwood. Also, so we know our heating elements back here. Let's talk about heating elements for a minute. I like the number 10, okay? If your heating element is at ambient temperature, that means it's not been running, it's not hot, it's just this temperature right here. You take off, I usually take off the neutral wire, take off one of your wires, put your meter in ohms, and then you touch the two screws, or a lot of times I won't touch the screws. If you look next to the screws, you'll see like a welding conductor or whatever, like the conductor. I like to touch, because the screw may not be tight. You know, it might be a little loose, like a loose tooth if the screw's not tight. So I don't really like probing the screw head itself. I want to probe what that screw is screwing into, if that makes sense. But with your meter in ohms value, you should get around 10 ohms, plus or minus, if your heating element is good. Okay? 10 ohms of resistance through your heating element. So that's checking ohms, checking current. Now you can do this part of it at the breaker panel itself. You don't need to actually gain access to the back side of this. And I've got a video on me doing this, and we'll make a link above of the video. I think Dakota and I were doing that. We were in the field. It was our third day. We were sleeping in the service trailer. It was our third day, and we were just checking the thing, and I think we made a video out of that. So we'll make a link to that to check the current going to the water heater. So you're going to go to your breaker panel. You can do it right here. You're going to get a clamp-on meter right here. You're going to get a clamp-on meter where your wire goes through the Hall effect part of it. Put it in amps AC, and then you're going to clamp around your black wire on the back of your water heater when it is consuming current, when the AC element is on and when the AC element, the heating element is energized. That is when you're going to be consuming the current. You're going to be consuming the electricity. You should also get around 10 to 11 amps AC through this wire. So if you could go through the circuit if you wanted to, if you had that kind of a meter. I just like the kind of the clamp around AC current should around 10 or 11 amps right up in there. And we already talked about 10 ohms of resistance at ambient temperature. So if we could check it here, we could also check it at the breaker panel. Overwhelmingly, your breaker panels, you're going to have one circuit breaker. It's usually about a 15 amp circuit breaker that says water heater. And the only thing on that circuit breaker is the water heater. And then you could get a little bit of slack out of that black wire that's coming off of that breaker that says water heater. You could check it there. So you can either check it on the back of this, or you could check it at the breaker panel, and that's what that video link is all about. So we've talked about the heating element. We've talked about the aluminum tank, winterizing. We've talked about check valves. What's this big black thing we have on the back here? That's a relay. Okay, so I'm going to put my meter down. on your, let me flip this one around. Okay, on your Atwood and the new Dometic water heaters, you're going to have a control board right here. Okay, I've got another video. I'm pointing to this guy right here. It looks like a deck of cards with wires coming out of it. Yeah, I've got a couple of videos where I talk about, so I'll tell you what, we're going to run out of room by putting them up here in the top. Go down to the description. We've got a lot of videos on explaining the wires, but what you're after, since we're still talking about the AC circuit, and I'd mentioned that the back side of this was a relay. Well, gee, what color wire do we have feeding this relay? A yellow wire. So I'm going to have 12 volts on this yellow wire, energizing my 12-volt relay, allowing the 120 volts to pass through the relay on the power side. So a relay has two portions. You have a control side of your relay, which we call the coil voltage. Remember, we would take a wire and wrap it around a nail and connect it to a battery, make an electromagnet. Yay. Okay, well, what could that electromagnet pick up? Well, it's a magnet. It can pick up whatever it wants to, depending on the size of the magnet and all this kind of stuff. But we have an electromagnet in this relay, and we call that the coil voltage is what's going to energize that magnetic relay to make it click, okay? Once it clicks, it could pass anything through it. In this instance, we're taking a 12-volt coil voltage. We're taking 12 volts to energize our magnetic field to close our contact points, and then we're going to allow 120 volts to pass through. The 12 volts and 120 volts never see each other. All we need the 12 volts for is to energize our coil, okay, our magnetic coil, to close those contact points. On one side of my contact point, I have 120. The other side goes to my heating element, and as soon as I energize my coil with 12 volts, magnetically it closes, like our nail with our wires wrapped around it, and then that 12 volts that's sitting on, our 120 volts sitting on one side, passes through, energizing our heating element. My point, AC troubleshooting, I need 12 volts on my white wire, and if the water heater's not at temperature, I need 12 volts on my yellow wire. The yellow wire is leaving my control board, heading back here to energize my relay to allow the 120 volts to go through to energize my heating element. Okay, yay. That's what's going on in the back. The new water heaters, I have them on the front. Since we're talking about AC, let's be fair. Let's talk about it on the Suburban right there. On the Suburbans, it's a little different. You have a junction box in the upper left-hand corner here. So here, what have they done? They've got an extension cord. So somebody did it this way. It's fine. Any port in a storm, right? So we have 120 volts coming in. There's my 120 volts sitting there. This should always be hot. The only reason this would not be hot at 120 volts is if you have a switch on the inside, and you can flip that switch on and off to turn on your water heater. Would be why this. But as far as the Suburban water heater is concerned, if we're going to pick up a trail from the water heater perspective, I need that hot right here, this junction box. Now you can't get to that because all you see is this front part, but know that it's there. The 120 volts comes in. Down here, there's a switch, an on-off switch. This one is seized. It won't switch for me. A lot of times those switches are $12 and they go bad. So 120 comes in here, goes to the switch. After it leaves my switch, it goes through the left-hand side of my push-to-reset box, okay? And inside of here, again, another video for sure, on it passing through the high-limit thermostat, which goes off at 180 degrees, and then it goes through the standard thermostat, which turns on at usually it's like 130. It's rated in C, so let's just say around 130 ballpark. But I've seen them, they used to have them where you can buy one that goes to 130, 140, but all this 120. But I think the default is 130 degrees. Your mileage may vary. It goes through here, and then it goes right down here to your heating element. Okay, so if you're troubleshooting the Suburban, do you have 120 volts here? Do you have it going through your switch? Do you have it going through your thermostat right into the heating element there? Heating element's good to get to, but you got to move all your gas valve to get it out of the way. On the DC side, so there's your AC show and tell part. On your DC side, looks like I have a gas train right here, so we'll talk about this one. This one is off of an Atwood. So let's say your water heater's not working on LP. So I'm done with the AC side, and if you need more, we've got videos more. But since this is a show and tell, because I'm getting ready to scrap all this stuff, I mean, I'm sure that control board's still good. I'll say this control board. I'm going to say the electrode, say the gas valve, but the aluminum scrap, I'm going to the scrapyard. So let's say that your water heater is not working on LP. It's going to probably be something with this. We need to verify that you have the correct LP pressure coming in to my gas valve assembly. Okay. Sometimes they call it a gas train. I like to call it a gas valve assembly. I want 11 inches of water column right here at this point. I want my ohms value on this. Most of them have a sticker right there. And I want my sticker, you do your Ohm's law, and you're going to calculate the ohms value on these things. Now, I do have links on our store. Go to our website, myeverywworks.com, click on our store link, and I found these solenoids on Amazon. There's two different types. They may or may not be in stock, but at least you can find them there and maybe get a part number and then go shopping. Okay, but if you buy them through that link, that's an affiliate link. But I have found these individual solenoids on the Amazon store. We need to make sure that both of these energize correctly. If one of them is bad, the whole thing will not work. It's a redundant system for safety. I'm going to come through here. I have come across one time where the gas valve was leaking LP. Okay, so know that the valve itself could fail. We see that twice on furnaces, once on a water heater. This adjustment thing, you take a little 1/4-inch nut, sometimes it's a Phillips. If you're at sea level, it's usually a little bit closed. If you're way up above sea level, you're going to open it. So this allows you, human, to adjust that flame. If your water heater sounds like a jet engine, you need to loosen that nut and adjust this to give it a nice, pretty blue flame. Here's a deflector on the end. So we're going to come through. There are spiders that make these webs that look like thick silk, and they like to get in here, and they will make a nest inside what you might call the J tube right here. So with the water heater turned off, I will get a can of that office, air keyboard cleaner stuff, stick the straw in here, and just kind of blow this J tube out. And oftentimes that might be the problem. But there's something else. I'm going to do the 80,000 foot view, but then I want to show you something else that it could be. So we want our deflector to be adjusted right. So LP comes in here, as long as the pressure is correct, great. Next stop. Are our solenoids both good? We're wanting the right resistance. I'm thinking around 40 ohms is what comes to mind through the solenoid. Then I want to make sure that my venturi is set correctly. I want to make sure that my J tube is not restricted. Light of spider webs in there. I want to make sure my deflector is here. The next thing I want to make sure is that my electrode is right in the sweet spot of where the flame is being spread. Now that gap right there should be about 1/8 of an inch. The trick there's a bug that's chewing on me. Please go away. The trick there is to get an Allen key, 1/8 of an inch Allen key. I just take yellow paint pen and mark that Allen key yellow, and that's how I check the gap. 1/8 of an inch Allen key, slide it between there. That's how I check my gap. If you're going to bend these things, try not to bend the one that goes into the ceramic, because if this one becomes like a loose tooth in that ceramic, this whole electrode is bad, and you have to replace it. Want to make sure I got a spark there. This goes to the control board. It's called the DSI board. I don't see one here. There may be one in that box there. It's that yellow manila thing that you plug into. I get 12 volts on the red wire of that little yellow manila thing. It's going to give me a spark. Once I get a spark, not only is it going to give me a spark, it's also going to open up my gas valve, introducing gas into my burn chamber here, right here. And as soon as I get ignition, it's going to start monitoring a small milliamp current through this wire. I used to know what the milliamp current is. It's a really small milliamp current. And that is how the control board knows that I have a flame, because I'm able to move current through this wire to ground, because there's carbon in a flame, and we're using the carbon in the flame to move my current to ground. Okay, now I really want to show you one more thing. What I am after here, here's your gas valve. This should be like a little brass fitting right before it goes to the venturi. There's a small orifice in there that we need to get to. Okay, so let's go to that. Okay, so basically, let me grab it and bring it over. So I just took 2 screws off. This J-tube comes off if you need to clean that. Sometimes these rust. The reason this was rust is it's sitting directly below your pop-off valve, and they start to rust. Well, this one's off of an Atwood. So here's an Atwood. But it's directly below the pop-off valve right here, and sometimes they rust, and you could just replace I'm calling it the J-tube. Why? Because it looks like a J. And this one's got a prettier brass piece. But so that comes off, and what I want you to notice is right here, I don't know where the angle is, there's that little orifice, okay? So I usually take an adjustable wrench. It's metric, but it's just on there. So you take this off, you clean it with isopropyl alcohol and a cotton Q-tip or whatever, and don't take your, what am I trying to say? Your MIG welding file and clean that. Don't do that. So, so what I've found inside of here is a little bit of a carbon buildup or a spider web. Now that looks good. I don't know if you can see light through there. Can you see? There's a spider web right there. Anyway, you should be able to see light through this little orifice-y thing. Okay, and then I'm going to look inside of there and make sure it's clean. If I'm really suspicious that it's not clean, then I will take 12 volts off of my test lead set. I will energize this with 12 volts, opening the solenoid, and I will squirt that office air through here, blowing out this gas valve with this orifice not installed. And that'll clean this out really well. Okay, and that's also a really good test to make sure that once this is energized, it's open on the inside. Okay, and I might keep that little piece. Like I said, I'm going to scrap all this, but I'm going through and I'm going to save little pieces like this and put them in my little parts. I would assume that this gas valve is probably good, so I'll just hang on to it. The electrode looks good, so there's no reason to scrap this. It might be the MacGyver thing that I need on a given day. But I did want to share with you about the this little orifice. That's a gotcha for some of you. Everything tests okay, but then there's a nest in there. We had a customer come all the way from South Carolina all the way up here to Washington, and it was a furnace job, but he had a nest. We got pictures of it, but he had a nest inside of here, and all we had to do was just take that off and clean it, and it was good. So there's your gas valve. That's off of the Atwood gas valve. The Suburban gas valve works on the exact same principle. Gas comes in, goes through our gas train, our gas valve. They do not have that adjustable venturi, but on the Suburban, hope this is adding value to you guys. On the Suburban, you could take this little curly Q thing off. I hope y'all can see. You can take this little curly Q thing off. That's like an anti-vibration loop that they put on there. And also just loosen this and squirt some office air through that as well. And then here's your whole J-tube electrode, just like before. On the DC side, on the Atwoods, it comes in on a red wire over here and goes through this side. The left side of your push to reset box is the AC side. The right side is the DC side. Now those little thermostats are not really interchangeable, and it has to do with the size of the connector part. I got a fat one and a skinny one. Also their orientation of angling left or angling right and where that reset button is. So you got to make sure you get the AC part number or the DC part number for that. Some wiring on the Suburbans. If you're replacing your Suburban water heater, they have changed some of the wiring on the newer ones. I think there's an orange wire now, and then a relay. And so you can really honestly, I've come across this a few times, and I'm like, what the heck? You know, it's not wired that way. If it was wired that way originally, great. But guess what? I'm usually replacing an old Suburban with a new Suburban, and the new Suburbans have this relay. The relay is usually going to be in this junction box. There's a relay in here. I want to say it's fed by an orange wire, and what they're expecting is, remember I said you flip a switch sometimes on the inside? Well, they're putting that orange wire in there because you can control the AC from a 12-volt source, just like we talked about with the Atwoods. And so what I've done, every time I've swapped out a Suburban, an old one with a new one, and it came with, I want to say, that orange wire with a relay in this box right here, I've just taken that relay out, taken that orange wire out, and wired it the same way. So that made it a lot simpler, okay? You rewire some stuff, but basically, I'm not going to wire that new water heater with the relay in it. And why would I not do that? I'm not going to do that because that's not the way it was originally wired. So then I'd have to pull a whole new wire into the RV, a whole new switch, a whole new everything. No, the circuit was fine before, so let's just wire their new Suburban water heater the same way as the one I'm taking out. So we have had some calls from folks that have requested, like, gee, how do I rewire this thing with this orange wire and the relay in it? I take the relay out, I take the orange wire out, and that leaves me with these wires right here, and everything works out just fine. Same on the Suburban. Cold comes in on the bottom, hot comes out on the top. Suburban has a steel tank. Atwoods are aluminum. This one's rusting. The reason it's rusting is because they never changed out their anode rod. Let me go get an anode rod. So here we have an anode rod. They're all of like 16 bucks. It's under $20. You got zinc, magnesium, different things. Well, gee, which one do I use? I think that's more a function of what type of water you're in, okay? So find out what kind of water you're in. I don't think one size fits all. If you have hard water, soft water, some different elements in the water, the magnesium or the zinc might react better for your situation, but do your own research on all that. I want to say these are magnesium. Yep, that's magnesium. That's a joke, by the way. So anyway, it goes in right here. The anode rod also acts as your plug. These folks never replace their anode rod. So when we pulled the anode rod, there was nothing here. There's a stick that sticks through, like a popsicle stick, and all this is put on the outside. Even the stick was gone. So all we had was a little bit of a plug, and that was starting to rust. So the inside of their water heater rusted. Now, I did put my bore scope in it, and that might be a fun thing to do. Leave a comment down below if you want to see me slice some of these things open. In fact, I do have some that are cut open over there. And I've got a video, again, down in the description, of me cutting open a Suburban and me cutting open an Atwood. But I think I stuck my bore scope in here. I want to say I did, and we were fishing around, and we actually could see rust inside this tank. So that's when we made the call. The customer made the call, let's just put a new tank in. So anode rod is your plug. On the Atwoods, let's talk about the plug on the Atwoods. See, I'm going all over the place. But anyway, my goal is to add value before I get rid of these things. Your Atwood, your plug is plastic. What did Darren say, huh? Anybody? Your Atwood has a plastic plug. I see people putting all kinds of plugs in there, but guess what? The spec is a plastic plug on the Atwood water heater. So let's just keep it to what the spec is. Why did they do that? We're gonna have to talk to the Atwood engineers, but all I know is the spec for the Atwood is a plastic plug. Please. And maybe it has to do with steel bonding to the aluminum. I don't know, but I'm gonna make sure it's got a plastic plug on the Atwoods, and I'm gonna make sure that the Suburbans have the anode rod. If you have to replace your pop-off valves, these are these pressure temperature relief valves. One's 3/4, one's 1/2 inch. Another trick that I'll share with you. If you're doing this professionally like I do, what I would recommend when you're working on these water heaters is this one is a 3/4 inch tap. I think it's rigid. I don't know how much the thing costs, but anyway, it's a 3/4 inch tap. I'm not tapping the threads, but I'm going to clean those threads, okay? So I'm just gonna screw this into the ports to clean the threads. So I have here the 3/4, and I just took paint pen and wrote 7/8 on there, so I got 7/8 sockets. Again, I'm not cutting threads, I'm just cleaning them, and this is the best way I know to clean it. Before that I was using a toothbrush, but it just makes sense to me. Let's clean those threads out, and here we have a 1/2 inch tap. So just get your 1/2 inch tap and your 3/4 inch tap to clean your threads whenever you're going to put a new pop-off valve in or a plug. Just clean those threads really good. They've certainly earned their keep. So what else can we talk about with these things? Oh, okay, I see something in here. This little jewel right here, okay, this guy, I call it a thermal fuse, okay? So let's say, and it's gonna be connected to our temperature thermostat and then our brown wire. So it only connects one way. Why would they do this to you? If that thermal fuse should fault, fail, trip, whatever, it's a one-shot deal. You can't reset them. Your whole Atwood water heater is dead in the water. It will not work, okay? Now, why would they do that to you? Well, let's say that there was a nest or something that got stuck inside of your U. This thing makes a U shape inside of your water heater. Again, go look at the videos where we cut them in half. Just go to our playlist, our water heater playlist. And, well, it got too hot and fire shot out of this thing. And it tripped this thing off. It melted it. It failed. And so they want you, human, to come in and look at what's going on. I'm going to tell you this. Be smart about it, boys and girls. But if this has failed, if this guy has faulted and you have confirmed that it's nothing in there, you can take it out of the circuit and you can connect your brown wire directly to your thermostat temporarily until you get one of these things. They're all like $5. I think they come in a 3-pack or something like that on Amazon. Go to our store. We got them. Amazon affiliate store. So it's a thermal fuse. Suburban does not have this. Only the Atwoods do. I think Dometic does as well. But I like it. It's another safety feature to your water heater. So I wanted to mention that to you guys. And basically, I think I'm done. So I'm going to be saving these pieces. So basically, I'm going to go through and save my control board, save the parts that are good on this, and then throw it on my trailer, and we'll take it off to the scrapyard. And it's funny, in Texas, we could get money for these things, but up in Washington, yeah, you just drop it off, no money. There's a place over by Gorst where the Navy Naval Yard is. I think if you separate it out, like this is aluminum, this is copper, this is steel, I think you can get money for it, but that's like a 4-hour job. I'm not doing that. So here we have the failure point right there. He ruptured right there. This one, they did not change out their anode rod, so the tank rusted. Okay, we haven't seen this guy over here. What's his problem? Oh wow, yeah, here's a good crack. So here's another one that cracked. See that crack right in here. Okay, so that's what's wrong with him. Is there anything in here we can talk about? No, I got another control board. And I doubt I would save my pop-off valve. They're $26, you know. The control board I'm going to save. So this one's frozen. It's weird up here. We never really get cold, but we had one cold snap that lasted all of 2 days. And we had like 10 water heater jobs. Information on this guy. Oh, this is interesting. So this is a Suburban, but this is a different design. I don't know if it's older or newer. Usually the Suburban serial numbers tell us the 22. Okay, so this on a Suburban, the first 2 digits of the year it was made. So this is a 22. I think this one has a cracked tank, or maybe it froze. Let's see here. Yeah, this one froze. Here, let's see if we can find that. Oh yeah. Okay. Here's what happened here. Big crack right on the side for that one. So we'll and then we got this guy. Like, would you want me to save this for you? I don't know. I don't think I'm gonna, because you can kind of go to a hardware store and get this kind of stuff. So I'm not gonna save this. For Canada altitudes above 2,000 feet and 4,000 feet, refer to installation manual. So high altitude conversion kit. So that's interesting. Here, I'm gonna hold that up. That's a high. Hold on, let me hold it straight so you guys can see. Get a model number, part number off that. That is a high altitude conversion kit. It looks like it's an orifice of some type. So I'm gonna hang on to that. But yeah, high altitude conversion kit, there's that information right there if you need it. That came off of a newer Suburban. Okay. Let's see what's going on with this guy, and then we'll finish up our story. This is an Atwood. We talked about the heating element on the back. If you have to replace your heating element, they do make this tool right here. I hate it because that is never a tight fit, and it slips. Anyway, sometimes in a bind, this is all you got. But that fits on the back of the heating element. Sometimes I get a big giant pair of channel locks to loosen it, and then this will help turn it off. let's see. What could we talk about on this one? He does not have a check valve. Looks like he cracked. Why is he here? That's big enough to pick up. I'm thinking he's cracked, but I don't know where he cracked. I don't know why else he would be here. Yeah, okay, he cracked right in here. You see this mess right at this seam here. He cracked. It's not going to capture on the video very well, but anyway. Okay, so guys, hope this helped. I just rattled off a bunch of stuff on these water heaters. I have them here. I wanted to share with you just stories from the trail. So I'm going to get busy trying to salvage off good parts off of this, and bid you adieu, guys. There may be a link below to a store worth conceiving of. It's just something we started talking about because I've been collecting these things knowing I'm going to be getting rid of them, and I'm like, well, maybe I'll get some parts off of them and we'll just put them on the shelf, used parts, and maybe if you need a used part or something. But I'm going to have them for these water heaters. I've got a couple. I've got an air conditioner I already threw away. That air conditioner is like from the 70s. It's nasty, rusted. But other things. So anyway, check out the store. Maybe we'll have it up by then. Anyway, Darren from Joyce. I'm going to salvage some of this stuff. Thank you for your attention, and I'll see you in the next video. All right, bye.